In this tutorial, I'm going to show you how to create slightly more complex programs. Once your students have got to know the programs in the Arduino laboratory and would like to try something more challenging, you can set them to the task, such as this one, an Arduino challenge. You could ask them to write a program to control the remote laboratory such that the LED blinks on and off for a second 5 times, the DC motor runs forward for 3 seconds and backwards for 3 seconds with a 1 second delay in between, and then the stepper motor makes 5 steps forward and then 5 steps backward at double step type and with a delay of 1 second between movements. And the above action should be put into the loop to run infinitely. Now the students will be able to get a lot of the code needed for this from the programs that already exist, but they'll have to be careful about how they compose the program so that they put it together correctly and so that the program runs. And one way of doing this might be to write a small program to tackle each of these parts first of all, store those programs, and then bring them back and gradually build up the larger program. So that's the way I'm going to tackle it. So the first task is to create a program such that the LED blinks on and off for a second 5 times. So let's get the blinking LED program. So the part that we need to change is the part in the loop. We actually want this to be done 5 times. So let's put a for loop in. Now this will have the effect of making the LED come on and off for 1 second 5 times. Now I know it's within a larger infinite loop, so this piece of code as it stands on its own will carry on switching the light on and off infinitely. But later on we'll take this section of code out and put it in the larger program, and then the 5 on and offs of the LED will be part of the larger sequence, which will include activity from the DC motor and the stepper motor. So for the time being, I'll store this program. I'll call it LED 5 times. Now let's get the DC motor code and see what we need to do to that. So the task we were set for the DC motor was that the motor runs forward for 3 seconds and backwards for 3 seconds with a 1 second delay in between. So we need the motor to run forward. We don't need to increase the speed, so we can take this part of the code out from the original program, and we don't need to decrease the speed. But we do want the motor to run for 3 seconds, going forward for 3 seconds, so we'll put a delay of 3 seconds here. And then we want the motor to run backwards for 3 seconds. And then we want it to run backwards for 3 seconds, so another delay of 3 seconds here. And we actually wanted a delay of 1 second in between times. So basically that's the code that we need, and we don't need the rest because this was to do with the previous program. For the delay, we'll actually put the motor on idle for 1 second. So motor dot run release. So here we don't need the serial print tick anymore because we're not doing the tick-tock program, and we don't need the integer I. So within the loop here we have the motor running forward for 3 seconds, then on idle for a second, and then backward for 3 seconds. We don't really need the serial output, so we'll take that out also. But we do need to set the motor on, and we need to declare the motor, and we need the library which has all the motor procedures. So now we have the code ready that will make the DC motor do what we were asked: run forward for 3 seconds and backwards for 3 seconds with a 1 second delay in between. So we'll now store this code. I'll just call it DC task. There it is. Now finally we've got a task for the stepper motor. The stepper motor makes 5 steps forward, then 5 steps backwards at double step type and with a delay of 1 second between movements. So we'll be able to write this code from the stepper code that's already written. So we need to keep the stepper library in, and we need to declare it that it's connected to the right port. We don't really need the serial output, so I'll take that away. We need to set the stepper speed. We want the motor to go forward. For how many steps was it? 5. That's not very many. I hope we're going to be able to see it. And they're meant to be double steps, so actually I'll put the 5 there. And then there's going to be 5 backward steps and a delay of 1 second in between. And for that 1 second we'll put the motor on idle. And I think that should be enough for that. Forward in double coil steps for 5 steps, delay of 1 second in between, and then backward. Perhaps we'd just put a delay at the bottom of the loop as well, so that there's a delay after the forward step and after the backward step. So now I'm going to save that as the stepper action. And there we have our new code. To actually put the code together, I think the easiest thing to do is to put it into a notepad file. So let's make a new notepad. Since we've got the stepper motor code here, we could start with that. So we take out the stepper code that we need. And we'll put it in our new text file. We don't really need the serial output, so I'll take that away. Oh, this is the original. So actually let's go back to the one that we saved. need to load the code and find the stepper action and load it. And now we'll take this code, copy it, and put it into our new text file. Now let's get the DC motor code. So I think we can take the parts we need from this bit by bit to build the program up. We've already got the stepper library, which includes all the procedures needed for the motors. So now we'll just take the declaration of the DC motor and put it with the declaration of the stepper motor. And then in the setup we have to set the speed, and we actually put the motor to idle also. And then in the loop part we have the code that makes the DC motor go forward for 3 seconds and then backward for 3 seconds. So we can pop that code in there. Now at the moment we've got a confusion about the motor names. We do have to distinguish the two motors, because at the moment we call them both motor, which isn't going to work. So since the DC motor is on channel 1, we'll make that motor 1, and since the stepper motor is on channel 2, we'll make that motor 2. So now we have to change the names throughout. And that should be the code necessary for the motor action. But we also need the code for the LED action that we actually saved earlier. So we can load code, and it was this one, LED 5 times. So what do we have to include? Well, we have to declare that LED is equal to 13, because that specifies the pin. That will specify the pin that will receive the output. And then in the setup we do just that. We initialize the digital pin as the output. So copy, and we put pin mode here. And then in our loop we need to take the for loop out, which makes the light switch on and off. And now we can put that into our loop in our new program. Okay. So hopefully this will work. We've declared our two motors and said where they can be found on the Arduino board, and we've declared LED as a variable to hold the pin number. So pin number 13 is going to have an output, and there's an LED attached to that. And then we set the speed of our motors, and then in our loop we switch the LED on and off 5 times, and then we run the DC motor forward for 3 seconds, leave it idle for a second, and then run it backwards for 3 seconds, and then we get the stepper motor to make 5 steps forward at double, and then we release it for 1 second, and I've just noticed a semicolon missing there. and then we get it to move backward at double coil, and then we have a delay of 1 second again. So let's see how that works. So let's grab it all and put it into our workspace. And now let's upload. Oh dear, we haven't got a laboratory. So let's schedule. It's 5:01. So we'll schedule for Coventry University Station, book it, and now we'll be able to go in. Have we still got the code? Yes. So we'll upload and see if it works. There's something wrong, so we haven't declared I in this test for the for loop. So we'll just declare I, integer I, and hopefully that will do the trick. Something else is wrong. Let's have a look what it says. Class AF stepper has no member named run testino. Okay, let's just have a little look there then. Okay, so for the stepper motor you can't use the run, so let me take that one out. There's no need for that one. So let's hope it works this time. No, something else wrong. Oh, I thought I'd taken that one, the run out already. Oh, there's another one there. Another sneaky run. So let's upload. And now we've got a semicolon missing, one of the oldest problems in programming. So where's that missing semicolon? Just right at the end. How many times have we done things like this? So we upload and let's see if it works. That's looking more positive. So now we see the light coming on and off 5 times. And now we see the DC motor spinning. And now we see the stepper motor moving. The stepper motor movements are very small because we've only asked for 5 steps. I think on reflection it might be better to set a challenge where we ask for more steps so that we can see the stepper motor movement a bit better. Let's change that a little. Let's make the stepper motor, well, shall we say 25 steps forward and 25 steps back? We should be able to see that better. We upload. So we see the light coming on and off 5 times. And now we see the DC motor moving. And now the stepper motor. And now the light again. In fact, I think I'm going to make the stepper motor move even more, because even 25 doesn't seem very much. So I'll put it to 50. And another thing I can see that perhaps isn't that good about this challenge is that the DC motor doesn't seem to stop. So what I think we'd need to do is to actually set it to have a delay after its backward run. If you look at the code, it runs forward for 3 seconds, then we'll leave it on idle for a second, then it runs backwards for a delay of 3 seconds. But actually we haven't got anything to stop it running backwards. So let's put a delay in. Let's make it idle to stop it. So we'll put motor 1 dot run release. And I hope that will make it better. So now we have the light coming on and off. And now it stops while the stepper motor goes around. So I think that's a better reflection of the task as set. But I'm just going to make it so that the stepper motor does actually move more noticeably. So I'm going to put it as 75 steps. So we have the light going on and off, the DC motor going around, stopping, going the other way, and then stopping, and then the stepper motor moving. And after the stepper motor has finished its action, now it's going back. It did 75 steps that time. We go around again and the light goes on and off, and then the DC motor moves, and then after that the stepper motor will move. So you'll see that this is not too difficult, but still quite an interesting challenge for the students. While you've watched me program this, you've seen me make some common errors that your students will make, and you can see how they've been resolved. We've got error messages given to us in the results section that's helped us solve the problems. And you've also seen an example of a logical error whereby the DC motor carried on turning when the stepper motor was going. And to solve that problem, we changed the code so that the DC motor was switched to idle after its backward run. So I'm going to just change the challenge that was set. So I'm just going to slightly change the challenge that was set, because we decided that 5 steps forward and 5 steps back didn't show very highly on the stepper motor. So if I use this challenge again, I'll probably ask for 75 steps forward and then 75 steps back. And now I'll save my code, because I know that this code works. So I'll call it Fun for Motors. And there's the code that we've written for this tutorial. So I hope this tutorial has given you some ideas of the tasks that you can set your students. In this tutorial, I've shown you how to create programs using that actually actuate the different devices. And I've shown you some common errors that will occur when your students are programming, so that you can see the sorts of programming problems that might come up. So I hope you've enjoyed the tutorial, and I hope that you have lots of fun using the Arduino remote laboratories.